Every AI model launches with the same headline: new model beats every benchmark. Nobody ever explains what that actually means, so let's actually break it down. Every major benchmark, what it really tests, and the strange stories behind each one. We're starting with coding, because this is where the story gets the craziest. The first real coding test was HumanEval, 164 handwritten Python problems. Give the model a description, it writes a function, you run it, pass or fail. Simple and genuinely useful. Instead of a human squinting at code going, looks fine to me, you just execute it and get a real answer. But it has one huge flaw. It's public. Every one of those 164 problems has been sitting on the internet for years. Which means a newer model might not be solving the problem. It might just be remembering the answer. LiveCodeBench tried to fix that by refusing to sit still. Instead of one frozen dataset, it continuously pulls brand new problems from competitive coding platforms like LeetCode, @Coder, and Codeforces. And it doesn't just check if the code runs. It tests self-repair, execution, even whether the model can predict what a program's output will be without running it. The whole philosophy: never give the model yesterday's exam. But here's the thing. Even fresh coding puzzles are still puzzles. Neat, self-contained, one right answer. Real software engineering doesn't look like that. Real engineering looks like users are getting logged out after changing their password. No spec, no hints. Somewhere in a codebase you've never seen, one line is wrong, and you have to find it. That's exactly what SWE-bench was built for. It hands the model a real GitHub issue from a real open source repository, along with the entire codebase, and says, fix it. The original version contains 2,294 tasks pulled from 12 popular Python repositories. The model has to explore the code, trace the bug back to its source, write a patch, and run the test suite, all without breaking something else along the way. This is about as close as a benchmark gets to asking, could you actually do this job? It became so influential that OpenAI built a cleaner version of it called SWE-bench Verified 500 tasks, personally reviewed by professional software engineers to make sure the problems were solvable and fair. For a while, this single number basically decided which AI lab could claim the best coding model on the planet. And then it started to fall apart. One widely cited analysis found that a top model scoring an incredible 93.9% on SWE. Bench Verified. Sounds like a nearly solved profession, right? Actually had close to 20% of its solved cases turn out to be semantically wrong once someone actually checked them by hand. The test said pass. A human reviewer said, no, this isn't actually correct. So OpenAI did something unusual. They went back and audited the benchmark itself. 138 of the hardest problems, the ones their own model kept failing. Professional engineers reviewed every single one. The result? At least 59% had real flaws. Broken tests that rejected correct answers. Vague problem descriptions that could mean two different things. The model wasn't always failing. Sometimes the exam itself was broken, so the benchmark had to evolve again. SWE. Bench Pro raised the difficulty and the diversity, 731 tasks, spanning far more repositories and harder, longer, more enterprise-scale problems than the original. And SWE Bench Multilingual pushed even further outward. 300 tasks across 9 different programming languages, including JavaScript, Rust, Go, C, PHP, and Java. Because almost every earlier version of this benchmark had one quiet limitation. It was almost entirely Python. Then came a completely different angle: terminal bench. Instead of just generating a patch file, it drops the model straight into an actual terminal and asks it to complete real command line work. Installing dependencies, debugging a broken environment, chaining commands together, interpreting error logs. Patch generation is one skill. Actually operating a computer, start to finish, is a different one entirely. And a lot of models that look brilliant on paper start making mistakes the moment they have to run real commands in a real shell. And there's Ader's Polyglot benchmark, which asks a narrower but very practical question. Can a model correctly edit existing code across multiple programming languages, Python, JavaScript, Go, Rust, C++, Java, using hidden test suites the model never sees? A model can be brilliant in Python and surprisingly clumsy the moment you hand it a TypeScript file. This benchmark is built specifically to expose that gap. So here's the honest state of coding benchmarks in one line. No single score tells the whole story anymore. One benchmark checks if you can solve a clean puzzle. Another checks if you can fix a real bug in a real repo. Another checks if you can survive an actual terminal. Another checks if your editing skills hold up across languages. Stack all 4 together, and you start getting something close to the truth. Rely on just one, and you can be fooled badly. Now, beyond coding, the same pattern repeats everywhere else in AI. For general knowledge, there's MMLU 57 subjects, from medicine to law to physics, all multiple choice. It became the standard measure of how broad a model's knowledge is. But once top models started clearing 98–99%, the test stopped being able to tell anyone apart, so MMLU-Pro made it brutal again. More answer choices, harder questions, heavier reasoning, scores dropped by up to 33 percentage points overnight. A lot of that old intelligence turned out to just be familiarity with an easy test. For genuinely hard reasoning, there's GPQA. Questions in biology, physics, and chemistry so difficult that even skilled people with full internet access average only around 34%. PhD experts in the actual field average around 65%. This one isn't testing memorized facts. It's testing whether you can actually think your way through something new. And at the extreme end, humanity's last exam, 2,500 expert-level questions built by nearly 1,000 specialists across 50 countries, specifically designed to stay unsolved for as long as possible. Frontier models have historically scored under 10% on its hardest questions. For pattern recognition, there's ARC-AGI, small visual puzzles where the model has to spot a hidden rule from a few examples and apply it to something brand new. Trivial for most humans, brutally hard for AI. The best system in 2025 solved just 24% of the private test set, and that was the winning score. For understanding images, not just text, there's MMMU, around 11,500 questions built from charts, diagrams, maps, and chemical structures across 30 different subjects. Because real intelligence has to include looking at something and actually understanding what you're seeing. For following instructions exactly, there's IFEval prompts with mechanically checkable rules, like use this word 3 times or write more than 400 words. A model can write something genuinely brilliant and still completely fail this test simply by ignoring what you actually asked for. For using real tools, there's the Berkeley Function Calling Leaderboard, testing whether a model can correctly call an API, search the web, or query a database, not just describe how it should be done. And for raw human preference, there's Chatbot Arena, no automated grading at all. 2 anonymous models answer the same question. Real people vote on the better response, and millions of votes build the ranking. It's not measuring correctness, it's measuring what people actually like talking to. So here's the real takeaway. There is no single benchmark that crowns the smartest AI. Coding has at least 4 different benchmarks that each catch different failures. Knowledge has multiple tiers built specifically because the easy version stopped working. Reasoning, vision, instructions, tool use, and human preference are all separate skills, tested separately for a reason. A model that tops one leaderboard can completely embarrass itself on another. So the next time you see a headline claiming a new model beats every benchmark, ask the better question. Beats it at what, exactly? Solving a clean puzzle, or fixing a real bug, passing a multiple-choice exam, or actually reasoning through something new? Because scoring high on a test and being useful at the actual job, those are not always the same thing. That's all for today in Dots and Arrows. Thanks for watching.